Now, this has parallel lines and a triangle and proportions all over the place. It's almost certainly a proportionality theorem question. And let's just start it here. They tell us some ratios. They say that the ratio of CF to FB is 5 to 2. And that's why I put a 5x from F to B and a 2x. I don't know how big it is, but I know that the ratio is 5 to 2. That's why I use the letter X there. And in CG to GA, CG to GA is in a ratio of 3 to 2. I use a different letter, 3y and 2y. Boy, this gives me a lot of information to be able to try the problem. Then it says, what is the ratio of FD to CF? Well, I ignore this 2x. Here's a triangle here. Those are parallel lines going through it. The proportionality theorem means that these ratios here have to equal the same ratios on the other side. That's why I know that FD to FD, the ratio of FD right here, 2 to CF has to be 2 to 3. But I call it 2Z and 3Z because I also don't know how big they are, but I know the ratio has to be 2 to 3. So FD to CF is 2 to 3. The proportionality theorem allows me to do it because AD is parallel to GF. Well, there's the first question done. Now, the next question is quite a bit trickier because you see this part here. They're asking about the ratio of BA to EA, this to here. I need this part here, this big triangle here and the AD that cuts across it. I need to figure out first how many Z's are there. Well, that's a little bit tricky. It was for me. This is how I did it. I don't know what this is here, this whole length here to 3Z, but it has to be the same as 5 to 2. So something Z to 3Z equals 5 to 2. And if I solve it, I get that this whole distance is 7.5. That means if that's 2 and the whole thing's 7.5, this little part here must be 5.5Z. Now that's pretty important because now I can get BA to EA. I know it's got to be the same ratio as 5.5 to 2 because that's what the proportionality theorem tells me. Well, the ratio of 5.5 to 2, make it a little nicer, multiply both sides by 2, it's a ratio of 11 to 4. Why can I do it? Because of the proportionality theorem and because AD is parallel to EF. Now, the next question is not hard if you remembered from your textbook or maybe looking at it before. It's all about the sine rule. I'm supposed to show that the area of this little triangle here, the ratio to the area of this little trapezium here, I have to figure that out. Well, first, the area of triangle GCF. It's 1/2 times the two sides, 3y times 3z, times the sine of the angle in between. The area of the triangle, of the big triangle, is 1/2 times 5 times 5. That's the bigger triangle, times the sine of the same angle. But I need the area of this little piece here. So I got to take away this little triangle again. So that's what I did. 1/2 3y 3z times the sine of c. Now the nice thing, you see this y and z and sine z, they can all factor out. And you just work with the numbers. 9 over 2, 25 over 2, minus 9 over 2. It's 9 over 2 over 16 over 2. You tip in times, and you get the ratio, which is 9 over 16. I guess that was pretty tricky. It was pretty tricky, but that's how you do it.